So here we're going to talk about our final specific component we're going to discuss, which is detectors. So once we've gotten our light from our light source and selected our specific wavelength with a monochromator, we need to be able to measure exactly how much light there is. We can't just say, oh, it's kind of bright or it's kind of dim. You know, we need something more scientific than that, a specific quantitative measurement that we can make. And to do that, we use a detector. So a detector is a piece of equipment that provides an electrical signal, generally, that's proportional to the amount of light that reaches it. So usually it's some sort of voltage or current that's measured that you can record with a computer or some other electronic recording device to be able to measure how much light is coming out from your detector that reaches the detector. So detectors are, the amount of response you get from different types of materials is very wavelength dependent. And so there's a chart down here, this is a figure from your textbook, that shows detector wavelengths, detector materials and their responsiveness at different wavelengths. So for example, if you want to measure something in the ultraviolet, use something like gallium nitride here, but it won't work past 375 nanometers. And so if you want to measure something in the visible, gallium nitride won't work there for various reasons with the material. So you can use something based on silicon, which is one of the most common detectors. So this is, for example, you know, often smartphone detectors will use silicon or things based on silicon. So the camera in your phone, which we'll touch on briefly at the end of this section, or things like photomultiplier tubes, which we'll talk about on the next slide. Or, you know, in the infrared, we use completely different materials because the visible materials won't work in the infrared. And so there's, right, you have to use the right tool for the job, essentially. And so there are different detectors that work at different wavelengths. There's no one material that works for everything. And so we have to design spectrophotometers kind of for each separate wavelength. So often in a UV visible spectrometer, you know, your response in UV may not be as good unless you have a detector that's specifically dedicated to those sorts of wavelengths. So when we're talking about detectors, we're going to divide detectors into kind of two main categories. So the first up here, detectors that just have a single element. So there's just one detecting element, you shine the light on it, and it gives you a signal. Another type of detector that's much more common in the ultraviolet and visible range is what's known as an array detector. And this is something that has multiple sensing elements built into it, arranged in some sort of array, usually either a line or a rectangle. And so cameras basically use array detectors, not basically, they do use array detectors to detect light that when we take pictures. But we're talking about this not just for taking pictures, but also we can use this for spectroscopic measurements when we combine it with the rest of a spectrophotometer.